were sitting around talking about this earlier, like, really, what is this whole NoSQL thing, and what does it really mean to the ones of us who work on databases? Because, you know, maybe we need a guide back to the NoSQL world. So what we did is I sat down and asked a couple people, like, what do you think about when you're thinking about NoSQL, and what are, like, the real things that are important to you that comes up? So, you know, at first we did, well, what is even the definition of it? Because it's even kind of hard to understand. We're saying, well, it's NoSQL, but what does that mean? Could that mean it's, you know, is that access? Is that, you know, what exactly does that mean as far as database stuff goes? So, non-relational data stores that do not need a fixed schema and that usually avoid join operations. I like that usually part there. There's actually a question mark where that was coming from Wikipedia. And the first thing I had to sit back and go, well, what does this really mean to us? So, a lot of us, we have group by. We've had group by, we understand group by operations. So to us, how do we translate this back down into their world and their terms? And so a group by operation, and the easiest thing to explain to it really is a group by operation is MapReduce. We're taking some data, we're coming up with a reduction operator, and then we're applying it. So MapReduce probably is maybe a new term for some of us, but in reality, we've all been dealing with this for a very, very long time as a concept. So, you know, if you're trying to explain to somebody in the database world and they say, well, what is this MapReduce stuff? You just say, well, it's really just a group by. And I'm like, oh, well, I get that. Just, you know, some. How does that work? You know, and then, but how do we translate this back onto the other side? Because, you know, in the other side of the world, we have the NoSQL world, where they're like, well, what really is joins? You know, what do they mean by, and they're like, well, we don't want joins. So since they don't want joins, what they're trying to do then is it's actually just a multiple MapReduce operation in their case. Because in their environment, there's no need for a join. We just have a lot of data out there, and we can just write something that can go access a lot of that data, you know, across nodes. And it's just multiple MapReduce operations. So that's what it means on their side. And, you know, on the same token, though, you know, we talk about things like table scans. So what really is, you know, in our world, you know, we try to avoid table scans. Table scan is the last thing you want to do. You don't have any index to your data. You don't know where your data is at. You have to find some collected, you know, you're going to have to go scan all that data to get an end result. So what does that really mean for their world? Well, in their case, that's a multi-machine category. So where, you know, we have it combined with a single machine, it's all about, you know, throwing that data out across as many machines as possible, scanning all that data, because, you know, if you don't have indexes, if you have multiple machines working on it, it does tend to work faster. So a lot of that's about a multiple machine MapReduce operation. On the same token, you know, we talk about things like order by with limits. So we have a data set, and we want to do some ordering operation of that data set. And you know, we probably want to have some kind of limits on that, so we don't really reply with too many given row results. In their environment, what they really have is they just call this natural data order. You know, what they're doing is they're storing the data in the natural order that it would ever need to be retrieved in. So there's really no reason for this concept of an order by. Which, by the way, if they do need one, the answer is MapReduce. With a lot of memory. So this kind of helps us out a little bit. On the same token, you know, we talk about what is the real features involving in these NoSQL databases. I mean, what are they're bringing out that are features? And so in this case, you know, we have something called, called a forward rolling log. A lot of these databases have been implemented, the NoSQL ones have been implemented with the concept that you take data and you apply it onto a log, and you have more data and you keep applying it to the log. And then as you have more data, you keep applying it to the log, and really shouldn't ever have enough data where the log ever gets filled. And this is a feature, and it's a feature that we've never seen anybody in the database ever be made fun of at all, ongoing, because we all know from our own experiences that there really is nothing wrong at all with just putting data on the end of a file. It'll never long-term go wrong for you. On the same token, you know, and this was Mark when he was reviewing the slides, he's like, yeah, reinventing my ISIM is not a selling point. On the same token, you know, they talk about the issue of like, you know, really there is no need for transactions. You know, we have eventual consistency. Why would you really ever be concerned about transactions as a feature? And I've got to say that within our own open source world, we know that there's never been an ongoing show. Just a side note, it's just really not having transactions is just fine. It's really never been an issue. On those same tokens, we look back at that and we think about the question of, well, schema-free, do we really require schemas? I mean, is there any reason why we go through, hours and days and months designing actual schemas?
I like my job.
Because, because really, schemas, because again, when I look at this, my thing is, I know where everything is. Please, because it's really okay to not actually have schemas. Really, when you get down to it, and their final piece of this is that, SQL sucks. As somebody who's worked on databases for more than a decade here, I agree, SQL sucks. I entirely do not like it. I sit back usually and try to dream up new languages and new ways of solving this problem. And I have to say, so far I've had no luck ever from anything. And when we look back at people and their response to it, unfortunately it probably is too small for everybody to read back to the audience. But when we look at these problems of how do we get around SQL, there must be ways that make people who work with us happy. First guy says, how do I query the database? The guy goes, hey, it's not a database, it's a key value store. Okay, it's not a database, how do I query it? You write a distributed MapReduce function in Erlang. The guy says, you just told me to go fuck myself? He says, I believe I did, Bob. SQL is really not much of the answer here, because that would be just too fast. And MapReduce, if we think about it, really is going to help solve our global problem. 6% of the power on the planet currently goes to data centers. And we know that MapReduce won't in any way require us to build many more data centers, just to help our global warming needs. So